Hello, in this video we are continuing using FBDK from HoloBlock, and as you can remember in the previous video we have created a model layer, a sketch for it, and today we continue extending a model layer and doing one important piece for it, integration of different conveyor models. So the last time we have created CNV loop MV model or system, and as we check what has been achieved so far, well, you can see again our 4 conveyor loop, and if I activate motor 1 and insert a workpiece for this first conveyor, the only place where the piece can be inserted, you can see that workpiece is moving. Let's try to make this workpiece to cycle depending on the motor values and of course workpiece availability. We are not yet controlling anything, but representing a model. So how actual object that we would like to control, in this case our control object is this conveyor loop, should behave well from environment point of view. And for this system, for the model layer, you may well recall we have been using CNV MDL file from MVA folder or library, and as the pallet was moving, it was doing so in 2 seconds, about 2 seconds to travel whole conveyor, as our speed was increasing by 10%. Well, each step we were moving 10% of the conveyor per clock. Now we need to think what to do with load and unload event from the model perspective, when and how to generate it. So we have load, unload. Motors values should be supplied from HMI in this case. Well, later as we add control layer, this would be coming from control, but so far it comes from HMI layer. And in this case our main inputs that we will work today are load, unload inputs, and in addition this end output, boolean output, to signal that workpiece has reached the end of the conveyor. If we look to our sketch of a system, we can think, let's start for integrating conveyor 1 and conveyor 3. In this case, what could be the condition for changing from one conveyor to another? Let me write it here at the bottom. So this condition could be having several parameters. First of all, CNV1 should be at the end, so it should have a workpiece at the end to be able to load to the next conveyor. And let's say CNV1 motor should be running, and as you could guess, also the motor of the next conveyor 3 in this case should be running. So this is a condition that can be checked for issuing a load event for conveyor 3 and unload event for conveyor 1. So think on the real case. If you have 2 conveyor segments, one integrated with another, so there are no any stoppers in these tasks, so it's just motors we have and this signal on the model conveyor layer that we have a workpiece. So as the conveyor motor will run, holding the workpiece, and the next would be running, naturally workpiece would be transferred. So we can think of it again as event I could denote it just AVT for CNV 1 unload would be generated in this case, and I'm using a bit, well, interesting notation here. It's, well, mixing of Boolean logic and some concurrent things happening, like in the case of events for loading and unloading conveyors. So that's what our expression, I can drag once again it here where it's better belong. So we will generate those unload events for conveyor 1 and load event for conveyor 3 if workpiece is at the end of conveyor 1 and conveyor both motors for both conveyors are running. So how to implement this? There are no well, somewhat ready block, or basically this is a good moment to check and generate own block for this purpose. Let's in this video see also how to create own block for the given task. So we need to have a free Boolean inputs, and as a result, and only if this Boolean expression is true, load, so event output for this block should be generated. Let's create such a block with free Boolean inputs. For creating the block, I'm going to back to the template folder and select the Composite block, a template, double click on it, and having a default template. Here is the name is given a Composite, and we will need to change it, and FB network, here we can update it. By default in this template there is one eDelay block, which we probably won't need in given example. Let me start by renaming the block. Double click, and we can call it CNV merge, let's say. So merging two conveyors on the model level. So let me also add suffix for it, MDL, CNV merge MDL. Let's call this block. Then when you're creating a new blocks, it's good to have or correct library assigned, and for this type of, well, new block, I would recommend in the beginning to use this student folder. So for saving your blocks. How to do this? You need to modify two things: compiler info, and change this default header and well, which points you to the template. We do not want duplicate things in the template, so I go here and change it to the student to have the right, well, folder, student package. And once again, this FBRT is Java well, notations, function block, runtime, and then student, and please be careful not to delete semicolon at the end. Okay, so compiler info has been changed. We see also, well, name of the block was changed as we were editing the name. And for saving it, let's again, as I click here, I modify to student as I click save button in the upper left corner. And in this stage, let's put just XML. We will be saving it as Java later on and compiling it. Therefore, once we have implemented the logic what we would like to have for this block. Okay, let me save it, and we see immediately as I press save button, we get highlighted a new block appeared within the student folder. So one additional important thing, where is the compiler we define? You need to edit under FBDK installation. In the folder you have editor ini file, and if you open it, let's say okay, let me start Komodo editor to really show you some of the things here. And as I'm opening in Komodo editor, you see in the third line you have a JavaC. As I'm using Mac operating system, well, it's a bit different path comparing to the Windows, but in my case it's version 91 or build, sorry, of 8th version of Java, and pointing to the location of JavaC, compiler, Java compiler. Okay, so, and you need to check where is your JDK, Java Development Kit installed, and where is compiler JavaC is located, and you need to go and modify before starting FBDK this line to be able to compile later on your projects. Okay, we check the editor ini for the initialization. We set the correct name, but now we start editing the interface. As I said, there is three Boolean inputs and one event output. So let's do it. This interface, and I'm deleting immediately unnecessary, in my case, in this problem, inputs and outputs. So let's delete also these default names for Boolean input and output. Okay, and let's start to add new variables. Again, I'm doing it all of this with right mouse clicks. And now for adding, I'm adding new variable, and it would be input variable of Boolean type, yes. And let's call it, well, input scene on, or in scene m, let's say motor value for the input conveyor. Then let's add another input, using similar template for out scene m for output motor, and then we have to add the third one, variable, sorry, not output, but of course input still, and it would be input conveyor end. So I have just generalized our inputs and their names for given problem, what was highlighted here. As you see, conveyor should be at the end and two motors would be on, but I'm trying to create now generic block, therefore I'm giving a generic name like in conveyor motor and out conveyor motor. By the way, one can ask why I'm not checking if there is any workpiece on conveyor free and just pushing workpiece independently if there is a workpiece or not on conveyor free. Well, once again, we are working here on the model, not the control. Such problems like checking if we are allowed to push from the application point of view anything to the next conveyor comes at the controller layer. Here we need to model things like they would be running from the environment point of view, controlled object point of view. So therefore, if one would forget, well, to turn off the motor from application or control logic point of view, and there would be motor running on third conveyor, and there would be workpiece, it would be pushed like it would be pushed in the real case. But let's carry on with our block development. So it has one event output. Let's keep it even this scene F confirmation event. What is still requires here is to interconnect, make the association between event input and corresponding, in this case, data inputs. And we need to connect all of them, and I just did it by in the same like we were interconnecting the function blocks, creating applications by alt key on the keyboard down and dragging dropping mouse. In some cases control key could also do the same job, and connecting things, associating things together. Okay, interface is ready. Let's start with the logic here, and there be network. And what can be logic? I deleted this default delay block, we do not need it. This is logical operation AND. And for creating, using those operations, we can check math folder to find their FB AND blocks. So we have 3 Boolean inputs and we need to do AND operation for it. Let's add this AND block. And let's call it AND1, just well, selecting default name. Then I drag and drop another one and call AND2. Why I have added 2 AND blocks? As I said, we have three Boolean inputs for which we would like to make AND operation, right? So, but default block over here from the math library gives us only 2 inputs. Well, how to create out of those blocks a block with 3 Boolean inputs, so how to process 3, you need 2 AND blocks. And you need to connect them in particular way. Let me first do internal connections. So this output would be going of the first block to the second block, and this in2 of the second block together with in1 and in2 for the AND1 block will be serving to input events from the upper layer or interface layer of Composite block. So how to make this? I do right mouse click and connect, and you see for, in this case, Boolean input in 1, I have a selection of different, well, inputs. And let me select in scene v1m, just as they are ordered on the interface layer, and then out m. There is also possibility to, if you wish, to add constants, but let's carry on connecting all the inputs that we have defined on the interface level, connecting it to this internal function blocks. Now, for the request event, we can also connect upper level rec event. So here it is. So what should be then coming here? Remember that we need to generate event only if those 3 inputs make AND logic gate and generate, well, true value. If I just connect here confirmation to the upper level confirmation, if I would connect it, it won't serve the purpose, because this confirmation event would be generated each time when this pure computation of this simple logic circuit would be done. So independently what would be here, the output, true or false, we will have a confirmation event. But from our application, and in this case model point of view, we need to generate this upper level confirmation event only if output is true. How to do this? We need to check other blocks we have in our libraries, and in particular in event folder or library we have block permit. Yes, here it is. Let's see it. Let me call it just small letters permit. And if I double click to check it, you can see that well, it has one event output and it has one Boolean in event permit. And if I test it, We can see that if I just click event input, nothing happens, but if I enable permit, yes, only then clicking or generating input event EI generates output event EO, but only if the permit is enabled or has true value, otherwise nothing comes outside. Exactly what we need here in our composite block. So I do connect now the connection with CNV and EO, and as you may get, event input here, and as you may guess, I connect permit. So now I'm able to connect this event output to CNV confirmation event at upper layer, a confirmation event, and we have implemented logic of the block what we would like to use. Let me now save this block. Okay, and let me click now Java checkbox to compile the block, and in the log we should see that if and as the block would be correctly compiled. Let me try it. Okay, we get a message that CNV merge MDL compiled. And one important thing, as you may naturally and iteratively develop things, testing the block, finding some, well, improvement, extensions for it, you may rebuild it, but as message suggests here, as you update blocks, if you have previous version running, you need to close FBDK completely and, well, start it again later on. So to check and see that the change you have introduced. Okay, so we have now compiled version of the block, and actually we can test it now. Let's run, and as you see we have our event, data inputs, and this request event, and I may try to press request, and you see nothing has happened, and I can try to activate some Boolean inputs and nothing is happening. Confirmation event is not activating. However, if I select all of 3 Boolean inputs to be true, let's see, yes, confirmation goes on, event goes through. So that's exactly what we intended to do. Let me stop the block, yes, just by closing the window, and let me try to introduce this block already here in our model for models for conveyors. So again, we need to have this event generated and telling next conveyor to be loaded or previous conveyor to be unloaded, and we can think where we can put this conveyor merge model block, and basically there are 2 possibilities. We can put either in the previous conveyor, so for in conveyor 1, where we would be observing the things, or we could put it in the next conveyor, and then we would be pulling. In either case, we need to pass values, like for instance end of the conveyor. If we would put conveyor merge MDL to the conveyor 2 to control the link between CNV1 and CNV3. Sorry, it was third conveyor, yes. But in this case, we will need to pass end parameter. So it would be more values, more data flow actually between resources. So from this design perspective, to minimize the flow of data between the blocks, it's good to put this block in the previous so-called arbitrary previous conveyor, and in this case in conveyor 1. And let me put here CNV1 to merge, name it, the block is added here, And for this block we need to have different inputs provided, and in particular value of motor and conveyor, in this case and of conveyor 1. Let me integrate it as the first data input actually to our block. So here it comes, and a confirmation event from here will be serving to unload the things and to be passed to the next conveyor. Let me do it according to the standard by introducing eSplit event events block, and let me call it in this case split, and integrating it here. Let me rearrange it a bit. Okay, here, and event output first would be going to command unload of the block, and next we will need to pass to the next conveyor. In our case it's conveyor 3. Okay, for passing I'm already going to the net library and selecting Pubble 0 block for publishing it, and let me call it CNV2. Let me call it just explicitly, and again you see the power of order 1, 2, 3. I always want to put here 2. Well, CNV3 unload. We see one block not initialized immediately, connecting init input to it. Okay, and request comes here to command unloading of the next, in this case third conveyor. So let's think now more where to get these values for our motors. First of all, last time we had created HMI, and in this HMI we have started creating conveyor 3 HMI. We see the label, but now we need to publish some of, well, value, and this value should later go to conveyor 1 and conveyor 3. Let's do it. I just jump back to the conveyor 1, making right mouse click, copying it, publisher block, just to have the right publisher block, publish, and using the same template, saying conveyor 3 MDL. And what I have to do, first initialize the things, and then just, yes, indication event should be connected to request event, and that's it. CNV3 mval is to get motor value. I am jumping back to conveyor 1 layer and adding here Subble 0 block to make a subscription to HMI. So it was CNV3 motor and val value. So it's separated with underscores. And again, one thing first is to connect unconnected inputs, outputs for initialization of events. Yes. And I can enlarge worksheet by right mouse click and making it larger. You see, now I can go and a bit work in the larger space, and a block is initialized. It provides us the value, and this value it should be not as you may guess, subel 0, but subel 1. Yes, once again, xinv1 underscore m and underscore value. It was third conveyor. Yes. Let's once again interconnect inputs, event input to point block initialization, and this read data comes to the motor. Okay, now one input was still unconnected, data input and event input request. Where comes request input? Remember that we have a clock pace that dictates us the update. In fact, this could be a good input and good source for telling and for calculating this network. So did we reach the end of the conveyor? In principle, there should be also int s used of the block which signals that we have reached the end of conveyor. Let's, by the way, use this rather than clock, but both are fine in principle. So let me connect it. So request event is now connected. It's a bit start to be difficult to see where comes what. Those we start to get spaghetti of connections, but with a small arrangement we get our request. And finally, motor 1 to be connected. In principle, it should be coming from the HMI layer. Let's try, and only to see that with these special blocks, subscription blocks, we can connect only one, have one output. And for this purpose, we need to have one, well, interesting hack, which is called basic block from math folder, which is what I'm using sometimes if FB or block as a hack block, and I can just call it or. Why or block? Because whatever it gets to its input, if, well, second isn't connected or false, it would be just transferring further. So I'm inserting this block in between and deleting previous connection, adding an input 1, and indication here can be connected to the request event and for calculating the logic, and this output now can be coming to different places, which are motor on of the given conveyor, and as you can see now I can add connection. We got also in motor connected. So we could immediately test if things working for us. Well, what should we observe as we run, and if things working? We should observe that workpiece would disappear at the end only if motor 3 in this case runs. Okay, we didn't yet implement it model logic for other conveyors, but at least it's good always to test immediately to spot any inconsistencies and mistakes we, well, can make. So I'm trying to save now the model. Let's see. Okay, saving is done, and let me run it. The model. Okay, I'm running a model, and we see workpiece runs till the end and stop there. Okay, it's not going further, but remember our condition that we should have also CNV motor 3 activated. Let's see. Well, and as I activate, nothing happens. So it's continues to remain here. At least no unload event has been generated. So let's continue debugging and checking the reasons for this. So first, what I can check. I can check that last time we have connected our indication event for sensor to the request event. And this is one particular issue with event-driven architectures to ensure that event would be generated later on. You can understand it that once in the conveyor 1 workpiece has reached the end of conveyor 1, this event was generated once and only then. But then there was some time passed before I went to the UI and clicked motor free. As I click motor free, yes, value has been updated, but there was no any event coming to the new block that we have added in the merge model to make again the computation for this logic. Therefore, it's good to come back and connect clock pace. So this is quite common issue with event-driven architectures and with understanding how the blocks going and operating together. So it's not a good, from our point of view, calculation point of view, way to have it there. Of course, there are different ways to implement. We can think about more complex condition of request, integrating events from indication and then integrating events from the motors, using several event split blocks, or, well, in fact, it should be event merge blocks, emerge blocks, and then providing requests. This is one way, and probably would be really in the spirit of event-driven architecture, just to have correct source of event. But in this case, I will be using clock pace event just to ensure that we have been calculating and updating things on the pace, not missing and forgetting some events connected. Okay. I'm going to the events library and add another split block to be in the spirit of IEC61499, and we have split already there. Split, let's call it pace, and again I'm disconnecting now indication event to link to the event input. And one of them goes to the clock and one would be used to recalculate things. So another good lesson we got with this example, and let me again validate, try things immediately to see that we are not missing anything else and we are on the right path. Again, loading workpiece. Again, I'm waiting for some moments and let's try to activate motor free. And as I activate, again, nothing happens. As I can see, okay, let's come back and see if we have forgotten anything else. So pace is provided to us. Data should have been generated to motors, to the end, to the input conveyor. We didn't forget to make computations for it. Yes, data was definitely passing through. Okay, let me just, out of curiosity, start it again, and let me just make one trick. I have already motor free activated and checking if there is, okay, motor free. Maybe I have misspelled outputs or inputs for the block. So how I call it, CNV free m val. Let me check here, CNV free m val indication event. Let's just double check how in bool should be behaving. Running it, providing some values, initializing the block. Okay, we got the checkbox. Let's see, indication, yes, it's correct. Indication event should be generated, and as we change the value, okay, and it goes to the publisher. Publisher has been initialized, and it's often, like you can guess from my reaction, there is no data was connected, and this is quite often could happen, that you can integrate inputs outputs for the events, but forgetting something. It's good always to spot the problems by constantly running. Okay, we have found the problem. Let's try to run it. I have been forgetting to connect data input. Okay, again, workpiece goes, workpiece stands at the end, and suddenly motor free gets activated. Perfect. Workpiece has been activated. As I was debugging a problem, here we have you may have seen that how this debugging was going. I was checking and generating correctly, well, for calculation of the logic, connecting to the clock pace, and then figuring out that some of connections were forgotten. But now you can see we can test it, have already several work pieces coming and disappearing. Good. So far so good. But now we need to continue our integration and defining things for conveyor 1, 2, 3, and 4. From the last time we have just naked block, not connected, and well, it can take, of course, especially as I speak, some considerable time to recreate these networks. Therefore, I would suggest you to do the following hack. Again, I'm going to the model level and I delete, well, those naked unconnected things in the model layer. So as we have tested something more elaborated, I delete for conveyor 4, I delete for conveyor 3, and I delete for conveyor 2. Okay, only conveyor 1 and clock is left. And then what I do copy conveyor 1 model and recreate it 3 times. And for this I will be giving the name CNV2 underscore model. Then, as you may guess, CNV3 underscore model. And finally, CNV4 underscore model. Okay, let's try to a bit reallocate it. So like, yeah, to have just a bit better arrangement. But what is good about this arrangement, or copying and pasting things again, in each model we have got the same similar structure as we had in conveyor model. Now it's mostly just editing and doing some cosmetics, like I'm now in conveyor 2, starting to change the name, and if we are good in following patterns, so pretty much it just would require us to change to identify valid indexes here, and conveyor 2, remember, is connected to conveyor 1 at the end. So let me close the loop. Let me just explicitly say by the blocks names that it's 2 actually and 1 connected, and it would be conveyor 2, a load value, and it should be conveyor 1 m value. Okay, sorry, let me see. Yeah, okay, there is already same name block, so we need to maybe follow the order. So this is conveyor to m value, and now I can probably rename this one. Again, I'm doing this renaming now, keeping in mind what is our logic, and I think this is, well, pretty much it for the moment. Of course, we need to be careful not to mess up with these indexes, but for me looks at the moment conveyor 2 done. I'm running to conveyor 3. Okay, changing it. Then what else? Here is coming conveyor 3 for view layer. Yes. Then conveyor 3 is connected. Let me think for the moment. Let me think. So we have been commanding. We have been adding publisher conveyor 3 unload. Actually, here I make another mistake. I think it should be conveyor 3 load instead of unload. So therefore here is the same logic. It should be conveyor 1 load. We should be commanding next conveyor to load, and here should be same logic, conveyor 4 load. So as conveyor 3 is connected to conveyor 4. And for motor value of the current conveyor, I again change the indexes. Okay, I need to follow certain order. Previous conveyor for us is conveyor 1. Okay, again I cannot change it. Yes, they are now both in mutual exclusion. Let me introduce, yeah, I cannot, just a placeholder. Here comes, I'm able now to put 3, and now here I'm able to put 1. Oof, I hope I won't mess up too much with these things, with these indexes. Once again, view layer, then it receives conveyor 3 motor value for itself, and then it needs to know the motor value of the previous one, true, and then it can command to the next conveyor also as and if we have reached the end of conveyor, to load the next one. And I think I need also to change those blocks value for conveyor 3. Actually, I see another place for optimization, but let's go further for the moment. Oh, sorry, let me put correct values. Conveyor 4, conveyor to load, can command. Again, it's merging of 4 and 2, yes, and for conveyor 3 model value, it's next output conveyor, so conveyor 2, let me see, yeah, I'm able to change it, and then conveyor 4 model value. Let me think. Here comes loading of the current conveyor, and in fact what we can see, we can actually use the same naming, 4 lval, 3 lval, 2 lval, and 1 lval, and we can harmonize with these blocks names here, publishers. So in this case it's better to call it CNV 3 lval. Then I come here, we need to command again just as a template to have CNV1 L value. Convert to can command to load, somehow send the signal to the model, and then here convert 4 can do the same for the second one, lval, and finally convert 4 to can command to load second. Again, let me just switch between and check 2. Okay, third should be for fourth, yes. Again, now I'm playing with indexes, we should be very careful. So third, first, I'm looking to this index. Third, first, fourth, second. Okay, at least there is no any repetition we have in the network, and I just used by the pattern, and then I'm checking some other blocks. 2, 1, 1. Here is a repetition, something is wrong. So for conveyor 2 is the first, for conveyor 3 it should be the fourth motor. Yes, the fourth motor. As I do this index update, I always keep in mind now this picture. So conveyor 1, conveyor 3, 4, 2. So therefore 1, 3, 4, 2. This order goes in this way. Okay, and the index is a bit, therefore 1, 3, and then 4, and then 2, if we think about execution order. Now, this is not the only thing. Remember that when we have been starting before, we have been having a disk. Then here we have had ring, if I recall right. Then let's put something different here, as for example peg, and then finally, okay, again I have a bit violated the order. Let's put here again in the third one to put their disk or ring, then in the fourth peg, and then finally in the second peg ring. So maybe it's good just to help ourselves and a bit rearranged to the execution order, just to minimize confusion caused by a natural numbering. Okay, most probably there is some indexes where mess up, but again, one way to check, as the template is repeated, I go to CNV1 and start to check with indexes. For instance, here 1, 3, 4, 2. So just to see that they're not repeating, then selecting next block, let's say this one, seeing 1, 3, 4, 2. Again, just that these are not repetitive, and here 3, 4, 2, 1. So it's kind of good signal that things are not repeated. Okay, this has been done. Now for the resource, we have been previous time connecting view value and having just here a presence. So let's interconnect them differently. And by the way, here we can also see, yeah, it was palette for conveyor 2, actually not the peg ring, and there is a ring and peg. But okay, let's already keep what I have changed at upper layers, and let's connect it here. And I just start to delete the blocks, previous publishers, and copying existing one, pasting, and just if we didn't mess up, if I haven't messed up with the indexes, I'm just in a very simple way can modify only the indexes and then deleting the next block, pasting for the third one. Okay, initializing it, first things first, and then finally deleting the fourth one, pasting new block, selecting correct index for it to have fourth, initializing. So it's pretty much to the copy and paste goes operations and updating valid values. Okay, and there were also colors, but okay, we can keep somewhat default ones. Position connected first, then style, and finally workpiece color. Okay, position connected, then let me delete this, style, delete, and then workpiece. And finally, for the last, conveyor 4, as it's in our view order numbering, so position, style, and workpiece. So if I have not messed up with the indexes, that's pretty much should be it. Okay, so we have yes, conveyor things coming, and yes, by default here workpack piece color were white. Let's change this. Let's again have, let's say, RGB, so which have red again, and then in this order let's put green. So second value to be 255 of the color RGB, red, green, blue, and then let's mix at the end red and green RG. So save. What else I have to do? We have defined our conveyor 3, and maybe for conveyor 2 and conveyor 4 I can do the same way I did for the conveyor models, just copying 2 times conveyor 3 and then editing, not screwing up the indexes, trying. So I go back to the HMI level, device level, deleting second one, deleting fourth one, and then copying 2 times, copy, paste, naming it 2, and pasting again and naming it 4. Okay, so it goes to the conveyor 4, third, fourth, and then second. Here we can try to arrange in the similar way, and you see that we have same indexes now appearing. Let's make them look properly. This is conveyor 4, therefore we would like to still see M motor 4 and publishing for the correct value. and then here is on the second conveyor, same applies here, and here for the indexes, for the namings. So once again, I hope I didn't make too much mistakes when I have been doing these indexes. Now one comment here, as you noticed at some point I changed the name, cnv_l val. We should be able to use the same for loading corresponding conveyors. Yes, and in case of conveyor 3, this cnv_l val comes from two places, from HMI1 of conveyor 1, and conveyor 2 should be also be able to load it. Therefore, the same block, publisher block, cnv_l val, comes here and can publish value for loading our conveyor. I'm curious to see what would happen. Again, just to double check, I have saved. And let's try to debug what was created and if anything would work. Well, first good sign what you can observe, workpieces disappeared now from all conveyors because good, conveyor has been initialized. Let's try to run, at least this part works so far. And then I need to put motor of conveyor 3. By the way, look, now they are arranged in the right order, as we have a picture also, 1, 3, 4, 2. And let's see what happens here. Workpiece disappears but not appears here, and debugging process once again starts. So why workpiece never appeared at conveyor 3? We need to check what happens here. Indication goes for the model over here. Yes, a load event should have been provided. Now let's double check cnv3l value. What we have here, cnv3l value. Yes, this is correct. Then what can happen that although we have provided correct values, maybe we didn't provide it to the next view layer. We see request event SD and name cnv3 view value. I am jumping to the view resource and seeing what is connected to conveyor. And immediately I see mistake I have made, forgetting connect indication events to the request event, right here. Forgetting this again, so okay, we have to separate a bit, yeah, but here to highlight for you. Now I'm a bit moving it, so I was forgetting to connect it. So nothing was coming to this level, and therefore I am adding request events. So again, another good lesson we got, seeing what happens when we forget some event connections and how debugging goes. I was going again through the publisher subscribers network. Let's see if this was it and if we will have our system running properly. Okay, I should have saved it. Again, well, first conveyor works fine. Then I go and load third one. Perfect. Disk appears here. And I try to load fourth one, and interestingly, when I clicked motor 4, you see it was conveyor 1 loaded. Why is that? My guess would be that I have provided wrong publisher event from conveyor 3 to conveyor 1, whereas I should have provided to conveyor 4. But let's check this hypothesis. I'm going to conveyor 3. I see CNV4L val. Okay, that seems to be correct, at least this point. Yes, but what happens here? I have init event here for loading it. Interesting. Yes, here was on the conveyor 4 we have been having a publisher for conveyor 1, not conveyor 4, so I forgot to update the indexes. But it's rather easier to update indexes. Again, I'm checking that all have correct unique indexes. It's easier to update indexes than just to recreate whole networks. So it's easier to copy and paste, and then with small debugging update indexes. So saved, and then let's see how it would run now. Motor workpiece in, and then what? Motor free, disk, or ring, and then I try to activate motor 4. Perfect. Gets the peg, and then let's see what happens here. Peg ring, and you see loop. I don't click anything, starts to run. We can introduce new workpiece, and sometimes you see it may not reach the end if you input like now. You see it has disappeared and the piece has continued. Well, it shows you clearly inconsistency, but remember, we are not yet controlling. As the model arrives and seeing that there is a motor running, it pushes its workpiece to the next conveyor, and workpiece simply disappearing. And already from the model level, you can detect such inconsistencies. So you can try to impose several, but I think, yes, the length of conveyor is the same in this example, so it's only 2 workpieces can, I think, exist simultaneously. Oh yeah, I was able to insert 1, but I think it would be hard to insert more. So, okay, dear viewers, we have seen how the model works, and you see if I insert or stop the motor, the loop stops, and by activating it again, let's say I disabled 1, but I activated 3rd one, it continues, so like it should be in actual life. So yeah, okay, that one got this. I can stop, continue, stop, continue. So we have implemented now so far a model which can help us detect inconsistencies if and as we continue developing control layer for our application. That was it for this video for today. See you next time.